Well, it does start with a K if you're in Germany, and that's where this concept was developed more. So instead of using C, we use K. K is for constant in the German language. Okay, so that's why they use it, if you're wondering. And by the way, C is used a lot. We use C a lot in our equations anyway. K is not as common. Okay, common with the C, because this is the English language. So yeah, it's just, that's all it stands for, nothing special. Okay, the second method, and again the preferred method we're going to use, is the B, proportion method. And this is the one you're going to use on these problems. It's going to be Y, and listen, I'm going to write something down. Don't be scared of it, just write it down, and then I'll explain what each part means. So Y, we call it Y sub 1, so there's a little 1 down there, over Y sub 2. Okay? And that equals X sub 1 over X sub 2. Do you guys remember that a little bit with slope?
Yeah.
Y sub 2 minus Y sub 1? Okay. But this has a different application, so we're not going to get it mixed up with slope. This 1 down here is called a subscript. Okay, so script, I think is a Latin term, stands for writing or written. Sub, what does that mean? Below, like submarine. So submarine, subscript, below the writing. So this is subscript. Do you guys know that there are numbers that are written up here? Have you ever seen numbers written? Those are called technically superscripts because they go above. Superscripts. Yeah, like Superman is above the average man. A superstar is above the average star. So that's why we have the superscripts, which we call exponents, and subscripts, which we're just going to keep subscript. Okay, ready? This is what it means. You see how this y and that x both have a subscript of 1? Okay, that's talking about the first instance of this variation. So in our first problem here that we're going to get, we're talking about money and hours worked. So can I ask you this real quickly here? As someone works more hours, in an hourly job, okay, when someone works more hours, what happens to their pay? It goes up. If they work fewer hours, what happens to their pay? It goes down. Is that a direct relationship? Okay. So here what I would put is I would put amount of money made on the first instance and the amount of hours worked on the first instance. And what they're going to do to you as the problem unfolds is they're going to give you either how many hours do they work if they make this much money, or how much money do they earn when they work this many hours. So we'll get to that in just a moment. Does this mean first instance, second instance? Nothing deep about that. Okay. Someone read for me example number 1. Yes, sir?
If it's 1, just like 1 and 2 like that, how could you differentiate between the whatever you're using, like hours, money, or stuff like that?
Yes. What I'll do is I'll use, instead of y and x, I'll use real variables like hours, I could say h, or wages or money, I could say m or w. So I can give it some value or give it some more meaning. But that's like the general way to write it. So can someone read example number 1, and we'll see how we use this little. Josh, go ahead.
Julio's wages vary directly as the number of hours that he works. If his wages for 5 hours are $29.75, how much will they be for 30 hours?
Okay, the first thing we have to get in this problem is what's the key phrase in that first sentence about variation? Anything about the variation that tells me this type of variation is going on? Let's go with James. You see anything in the first sentence that tells me what kind of variation it is? Varies directly. So that's the key right there. So I know I'm going to use this proportion right here. This is my proportion. Okay, so I'm going to give it some more meaning. What varies directly to what? So what are the 2 factors in that problem? First factor would be wages. How much money he makes. That's what it means by wages. What's the second factor? How many hours he works. Okay, so watch what I'm going to do. The wages, I'm going to say wages are y. W sub 1, W sub 2. And then what's going to be x? Instead of x, I'm going to use, what do you think, for hours? H. Okay, so I'll use H sub 1, H sub 2. Okay? Ooh, wine high. All right, anyway, that's what I have right there. Okay, looking at the problem, what was the first instance of his wages? What's the first mention of his wages? Ellie, what do you think? Yeah, so what is W sub 1? So what does it say in the problem?
29.75.
Yep, he makes $29.75. That's the first instance of his wages. Do they give me a second instance of his wages? No. So you know what? I don't know what the second instance is. I'll just call it W. I don't know what it is. Yes, sir?
That means he's making below minimum wage.
Yeah, and this is again like 20 to 25 years ago. So the amount of money was more significant back then. It's not going to be very much now. But yeah, so think a long time ago. When I was still a boy. 25 years ago. Yeah, I was 6. 25 years. Man, that's...
You're 31?
Yeah, I guess I am.
Oh, sorry.
That's okay. All right. What's the first instance of his hours? Oh, my. 5. And do you see how 29.75 relates to 5 hours? So you see how they kind of go hand in hand? Okay. And then what's the second instance of his hours? Does it say anything about hours again? Anything about the hours again? Harper? Anything about the hours? So 5 hours I got. Sorry? I don't know per hour just yet, but I do know that it says something about hours again. It says another thing about hours.
The value of K is the amount of money
Look at the problem. I'll have Wyatt help you out. What's the second instance of the hours in the problem?
I know it, Mr.
It's 30. Right? It says he makes $29.75 after 5 hours of work. How much money will he get paid after 30 hours? So that's the second instance of the hours. So how do I solve for W? Cross multiply, but what can I do first to make my life easier? Yes, sir?
1/6.
Yeah, I'm going to change this to 1/6. So I'm going to write 29.75 over W equals 1 over 6. So just reduce fractions if you can. And that's okay. You did that. So here you're cross multiplying. And you're really doing 29.75 times 6 equals W times 1, which is what? W. So your whole mathematical problem is 6 times 29.75. Which is what?
$178.50.
Yes, ma'am.
It's like the 4th time I've done this problem.
Genius.
Oh, yeah. Practice makes perfect. Okay.
No, it's all you.
Actually took it, it wasn't easy.
You're right. Oh, my. Okay. After 30 hours, how much does he make?
Well, that's not much.
No, and again, 25 years ago, this would have been more. Okay, let me ask you this right now. Ready? Okay, do you remember how we talked about 2 instances of hours? So we had the 5 and the 30. You guys remember that? And then we had the $29.75. Okay, ready? Please listen. These two vary directly, hours and wages. You okay with that? So when one goes up, the other one goes up. One goes down, the other one goes down. Okay, what happened to the number of hours? From 5 to 30, it went up. So what should happen to his pay? It should also go up. Did it go up? Yeah. If you're working out this problem and you get like $20.50, so you're telling me the more someone works, the less they get paid? Not in this instance, although technically... There's, no. You know when it would happen? It does happen.
Yes, I would like
When? When you paid by salary. So if they gave you a yearly salary, they gave you $200,000 a year. You can work 80 hours a week or you work 40 hours a week. You're still going to get paid that $200,000.
True.
So that does happen.
Yeah.
Well, if you just work an hour, would you pay that much?
Hourly?
Well, no, because you
Hourly.
still.
You might get fired.
You still.
Yeah, you might get fired.
I mean,
You might not do your job so well, and then you're done. But anyway, just ask some of those head coaches. Oh, sorry. And I'm talking about all sports now. All right, let's do another example that's actually very straightforward. It's actually not very hard at all. It's example number 2. I'm only going to go through one method because the second method seemed to confuse the others, and I'm not going to bring that up. It's just a little bit too much. So example number 2. If y varies directly as x. Do you see the key phrase? Varies directly, okay? Because they're going to tell you varies directly or inversely. Y equals 28 when x equals 7. Find x when y equals 52. What? Let me read that again. Okay, listen to me right now. These problems are going to look just like example number 2. So number 2 is where you really got to focus here. It's going to tell you using the English language, using proper grammar and structure. If you can't interpret it, you need to practice this because it's telling you exactly what's going on here. Let's break it apart. Varies directly means this. I have this. Varies directly automatically means this. I use this proportion. Varies directly. Please don't forget that because it's different for varies inversely. Do they give me the first instance of y? Do they give me, and what would that be? Okay, so instead of y sub 1, I'm going to put 28. So I'm just putting everything down here to substitute the values. All right. Do they give me a second instance of y? What is it? 52. So I put that right here. So far, so good. I'm just plugging what I know. Plugging in what I know. Do they give me a first instance of x?
Yes.
What is it? 7. Do they give me a second instance of x?
no.
So I don't know what that is. So there are many ways to work this problem out. There are easy and hard ways, and wrong ways, which I hope you don't do. But what's an easy way to do this one here?
Simplify.
You can simplify, cross multiply. Ready? What's 7? 7 times what equals 28? So x times 4 equals 52. And you're like, that doesn't help me. What's 28 divided by 4? 7. 52 divided by 4 gives me... So x will equal 30. No. You guys would have known this. If you just looked at it, you would have gotten it. But let's say for example, you're like, wait, what just happened here? And you just want to cross multiply? You can do that. But what would I recommend you do with fractions before you cross multiply? Simplify. Just make life easier for yourself. So this would simplify to what? Somebody? A little bit more. It would actually simplify to 7/13. You would be left with that. 7 times what equals 7? 1. 13 times what equals?
14.
Or if you're like, Mister, I still don't see that. Why don't we just cross multiply? All right. 7 times x equals, what's 13 times 7? 91. Okay. Divide both sides by 7. You get x equals 13. Wow. Sorry, I had a mental block there. And you get 13. 13, 13, 13. You can do it. And listen, I want to make this plug in here since you guys seem to be understanding it. Whether you did it this way or that way or this way, do you realize that there were, on this problem, 3 ways to do the problem? There is structure to the problem and there's also flexibility, which means creativity. If you want to do it this way, have fun doing it. If you want to do it that way, fine. If you want to do it up here, have fun doing it. But just make sure you should get 13 on all of those. That's the answer. Okay. Let's finish up here. Last one. So this is Roman numeral number 2. And this is inverse variation. We're talking about inverse variation. Okay, I think I spelled that right. Yep, inverse variation. Okay, yes, sir?
So with direct variation, itself like what we do with the triangle
proportion. Yeah, and then remember, Hayes, you brought up on that lesson, I think, the scale factor. Like, you could say this number times something equals that number on the triangles, and then that same number would be the multiple. This is actually relating to that as well, which is really cool, using the equation method. So, yes, you brought that up earlier, much earlier as well. Thank you. All right. Inverse variation. There are two ways to do it. The first way is the equation method, which I would call superior to the proportion method for this problem. But that would look like x times y equals k. X times y equals k. And some of you already said direct is this. One goes up, the other one goes up. One goes down, the other one goes down. Inverse variation should mean this. One goes up, the other one goes down. And vice versa. One goes down, the other one goes up. This would show that relationship. But the way we're going to work it out is just using the proportion, but a little bit different this time. Okay, ready? Y sub 1 over y sub 2. Nothing's changed so far. That's nice. But the second ratio is different. X sub 2 over x sub 1. Because it's an...
Because if one goes up and the other...
Oh, yeah.
See how it goes 1 to 2 is just going down, and it goes 1 to 2 is going
Yeah, because if this is going to go up, that has to go down. And if vice versa, that would also have to happen, which is cool. It's a good mathematical relationship. Let's look at example 3, a practical, for some of you who play instruments. Anyone play a stringed instrument?
We don't do strings.
No one does strings? Oh,
I
oh, you do? What do you play?
Violin.
Okay, oh, so this is a violin. So this is related to that as well. Okay, Lisby, can you do me a favor? Can you read that example 3? All right, go ahead. I'm going to listen to example number 3. Okay, go ahead.
The length of the violin string varies inversely as the frequency of its vibrations. A violin string 10 inches long vibrates at a frequency of 512 cycles per second. Find the frequency of an 8-inch string.
Okay, so hopefully you kind of look at that problem, and if it doesn't make sense the first time, you know what I do, and I've done this so many times, just read it again. Oh, okay, that's what it's saying. Whatever, it clarifies it. Okay, you have a violin string of 10 inches. It vibrates at a frequency of 512 cycles per second. What happened to the length of the string from the first instance to the second? It went from 10 to 8, so it went down. So what should happen to the cycles per second? Should go up. It should go up if it really varies inversely. Okay, so we're going to use the second method right here for example number 3. And we're going to replace these. So what varies inversely to what? The length of a violin string. So I'm going to call that L. And I'll do capital L. L sub 1 over L sub 2. Varies inversely as the cycles per second. So what variable do you want?
C.
All right, C is fine. I'm going to call it C sub 2 over C sub 1. Don't forget that they get switched up a bit. That's okay. All right, what's the length of the first instance? So what's the violin string length in the first instance? It is 10. What's the second instance? 8. Right? It went from 10 inches to 8 inches. What was the... Now be careful. What was the first instance of the cycles per second?
512.
So where should the 512 go? Top or bottom? Bottom. It goes on the bottom. 512. And I don't know what this is. I don't know what that second instance of cycles per second, but I know that it should be bigger or higher than 512. We'll see. What can you do here to make... What can happen here to make life easier for you? Yeah, so can you do 5/4 equals C over 512? Yeah, if you're going to do this right here, yeah. Are you going to cross multiply?
Or I meant to say, like, if you divide 10 and 8 by 2, then you divide
Oh. So when you're dividing 10 and 8 by 2, you're actually dividing it by 1,
My bad.
which is cool.
Sorry, I had like a brain.
That's okay. You're just dealing with the fraction itself, but yeah, I see what you're saying. Okay, so sorry, 512 times 5 equals 4 times C. Go ahead and solve C, 4C, I should say. Okay, 5, 12 times 5, 10, 6, 25, 60. Okay, 25, 60 equals 4c. And then what do you do to both sides here? You divide by 4, 6, 4, 0 equals c. So my answer is going to be 640, and to be, accurate, cycles per second. And if you understand frequency, what does that even mean? So you know how you have your string? Okay, when you pluck it, either with the, what do you call it? Is it a stick? What do you call that? What do you... Mm-hmm.
The bow.
The bow. Wow, that was bad of me. Sorry, Swivl. The stick. A.K.A. the bow. Okay, the bow. Yeah, so you're taking the bow, and what happens is this. When you strike that 10-inch bow, or string with the bow, it makes that bow vibrate, doesn't it? Okay. It doesn't? String doesn't vibrate?
No, the string vibrates.
Yeah, the string vibrates. I'm sorry, I'm mixing up my words. When you strike the string with the bow, the string vibrates. I'm sorry, yes, you're right. Okay, when the string is shorter, how many cycles does it go through? When the string is shorter, it should go through more of those cycles instead of fewer. And it's mathematically that way. I didn't decide that way.
You should have.
Mm-hmm. Yeah. All right. Anyway, let's do our last example here. We're just dealing with numbers, which is easy. Hopefully. Example number 4. And there's a key phrase in here that should tell you exactly what to do. And it is the phrase in example number 4, varies inversely. Once it says varies inversely, I'm like, okay, it's got to be y over y1 over y2 equals x2 over x sub 1. All right, that's what it has to be if it said varies inversely. And then all I have to do is put in the numbers where they belong. So I'm just going to start calling on people, and you're going to give me the required information. So, Kyra, what's the first y? What's the first y in example 4?
5.
All right, so we're going to substitute it with 5. All right. Beth, what's the second y? Thank you, Beth. What's the second x? Margot.
I got X.
Okay, we don't know what it is. And what's the first x? Eli. 15. There you go. You just got to put the numbers where they belong, and then you can cross multiply, or you can find any other method. 3 times what equals 15? 5 times 5 equals...
Well, we can do it mentally. Did you say we can do it mentally? I like the ball.
Okay. Let me give you... Oh, nice. Ezra. He's doing better. Titus got it, and my wife got it. So now we got 2 down. Let me give you your homework here is 13 to 29 odd. And then number 34 as well.
Thank you, Mr. Hubbard.
Wow.
Yeah, Mr. Ray.
Thank you. Mr. Hubbard's over there. All right, anyway. Let me help you out in the first few problems. You still have a few minutes, thankfully. So please listen up because I want to help you out on those first ones. They're a little bit tough. Okay. If you're listening, you will be able to answer these questions. If you're not listening, then it just goes right by you and you're like, I don't get it. Okay. There are 2 types of numbers. There are constants and there are variables. Constants are numbers that you know and that don't change. Variables can be one thing or another. It varies. That's why they call them variables. Okay, on number 13, determine which equations represent inverse and which represent direct variations. Then find the constant of variation. Okay, I'm going to help you out whether it's indirect or direct, but you need to tell me what the constant is. All right, so number 13, it is indirect, and that's related to the equation method. Just write I for 13, right? I'm not requiring you to know this on your own, but I do need you to know what the constant is on number 13. What's the only number that will not change out of those? 15 is a constant. It stays. It's the same. R and S can be different things, but not 15. 15 is 15. So I, 15 is your answer for number 13. Mr. A, I didn't get number 13. I'm sorry, I gave it to you. Number 15 is also indirect. Indirect. Because as one goes up, the other one goes down, and we didn't have time to go over the reason why, so just put I. What's the constant? I'm waiting.
It doesn't exist.
Oh, 15.
9. The only number that never will change in that equation is 9. 9 is a constant. You got it, Walker. Stick to your guns on that one. You had it. You said 9. It's 9.
Yeah, I ran out of sticky.
Okay. Yeah, I got it. I'm interpreting this right now. 17 is a direct variation. When one goes up, the other one goes up. When one goes down, the other one goes down. What's the constant?
4.
Ooh. Did I hear it?
4.
That's correct. 4 is the answer. See, that's oh my.
Wait, do we put I?
You put D and then comma 4. Goodbye, Swivl.